Hello guys, welcome back to another video. So today we'll be doing analytical geometry and I will be covering up grade 10's work. So you have to know analytical geometry for your June exams, and without wasting any more time, let's get into the video. Now with analytical geometry for grade 10 specifically, you have to know how to calculate distance, how to calculate gradient, and how to calculate midpoint. And also you will be given you need to be able to calculate gradients of perpendicular lines, which they have to give you gradients of two lines if they give you -1 when you times them, which means they are perpendicular. So in this video we'll try to do some questions to learn how to calculate distance, how to calculate gradient, how to calculate midpoint, and how to calculate the equation of a straight line using gradient and points on that graph. So let's start with, you can see the first formula there, it's distance, x2 minus x1 squared plus y2 minus y1 squared. So we will be doing an example where we will be practicalizing this formula to be specific, and after this formula we'll go to gradient and midpoint. So in this video I will be covering up all these formulas you see on your screen, and let's do that. So here we are. Calculate the distance between the following. We have point A here, it's -2 and 4, and then point B we have -1 and 9. Now this is 1 and this is 2. So how will you know? They will be indicated by the alphabets to know the alphabet that comes after the other, if that is 1 or it's 2. So here in this bracket we are going to start. X2 is here, that's -1 minus and -2, and then we will square all that, and then the following one is the y's. This is y2, this is y1. Then you will have 9 minus 4, and that we will square. So you put all of this, you can put all of this in the calculator, or we can just go further to say, before you put in the square root, to say here we have 1, and then this side we will have 25. So 9 minus, yes. So when you put everything into the calculator, so guys, let's just put everything into the calculator. Then AB will equals to root 2.6, which is 5.1. So that will be our answer. Sorry, not root 2.6, that is root 26. Root 26, but this will be like this. When you round off, it's 5,019. So when you round it off, it will be 5.1. So that is the distance. Now that is the distance between 2 points. Now we can learn how to use the gradient formula. Okay, so here we are given another example. So we have to calculate So we have to calculate our gradient. So we have point A and point B. And now what is needed from us is for us to calculate the gradient. So firstly, we are going to substitute what is to be substituted into the equation. So this is y2 and this is y2, this is y1. So we're gonna have AB equals to 1 y2, and this is 1 minus 3 all over x2 is 3 minus negative 3. So you're gonna put that into the calculator, and that is 1 minus 3 all over 3 minus negative 3, and then A B equals to negative 1 over 3. So that is the gradient for this line. We have determined our gradient. Now what we are going to do that's a bit interesting is try to calculate perpendicular lines, gradient of perpendicular lines. All right, here we have our triangle on a Cartesian plane, and we are asked to prove that these lines are perpendicular. So B is negative 2 and 1, and the point here is 1 and 3 for A, and then for C is 0 and negative 2. So this represents the x values, and this second one is the y values. What we are asked to do here is to calculate whether the gradient of this, we are going to take A and B, and then B and C. So if their gradients are equals to negative 1 when we times them, which means this angle is a right angle triangle, right? Perpendicular lines are these lines that meet here at 90 degrees. So, which means these two lines meet at 90 degrees when they are equals to minus 1 when you calculate the gradients. So we are going to start with gradient AB equals to y2 minus y1 over x2 minus x1, right? And then when you substitute your values, you are going to get that yb is 1, yeah, yb is 1, and sorry, it's ya, yeah, yb is 1, and then ya is 3. So that's going to be 1 minus 3 all over xb is negative 2 minus 1. So put that into the calculator and you will get an answer of 2 over 3. Now the next thing we are going to do, let's write it down. AB equals to 2 over 3. Now let's just change here, and this will be BC, B and C. So C is y2, then that is negative 2 minus this one over 2 minus 1 over negative 2 minus 0, and that will give us 3 over, that will give us 3 over 2. Oh, sorry, here x2 is supposed to be 0. I swap them around. Yeah. Let me fix this first. Yeah. 0 minus negative 2, and that will be equals to negative 3 over 2, right? So we have to say AB times BC. So that's 2 over 3 times negative 3 over 2. Let's put that into a calculator. 2 over 3 times negative 3 over 2, and that is equals to negative 1. So we have proven that these lines are perpendicular. Yes, now we are going to be calculating the midpoint. As I have shown you that we have to calculate the midpoint of these 2 points, and the midpoint is x1 plus x2 all over 2, and then y1 plus y2 all over 2. This is the formula of the midpoint. Now what we have to do is to calculate, substituting all that needs to go. So this is x1 and this is x2, so that will be 2 plus 6 all over 2, and then we will have 8 and 20, 8 plus 20 all over 2, and then what we will get is that 2 plus 6 divided by 2, it's 4, and then 8 plus 20 divided by 2, that is 18. 8 plus 20, yes. Let me double check. Oh, sorry. That is 14. So 14 and 4 and 14 are the coordinates of the midpoint. So the point between these 2 points that cuts them into half will be 4 and 14, and that is the midpoint formula. Okay, and that is all for grade 10s. With this, let's see. Okay, with this, guys, you might be given a distance, right? Let's say a distance between point A and point B is this much, right? Now you have to calculate 1x, right? So you still use this formula, or you can be given the gradient for this line is this much, and then you don't have x. So you can still use these formulas to find the point, or this one. You can still use this point to find x and y. You may not be given x, those x and y's that we substitute in order for these equations to be complete. So that's what you have to keep in mind. But next time I will be doing question papers. After this, I will be doing more of analytical geometry for grade 11s to see what grade 11s have to know for analytical geometry. But for grade 10, this is as much as you have to know. Thank you very much for watching. Until the next one, don't forget to like, subscribe.